Okay, so we're going to do some of these problems. The first one is a silicon chip used in an integrated circuit. So we are starting with our 5.68 milligrams. And we know that there are 1,000 milligrams in 1 gram. Now, we're trying to get to atoms. So we can't do anything with going directly from grams to atoms. So we have to go from grams to moles. So we know that there are 28.086 grams of silicon in 1 mole of silicon because that's on the periodic table. And then we can multiply by 6.022 times 10 to the 23rd atoms in 1 mole. Okay, so then I get 1.22 times 10 to the 7th atoms. All right, so that is just basically going from mass into moles, and then we're going from moles into atoms, and that's what it's asking. How many silicon atoms are present in the chip? All right, so now we have cobalt. Now we have atoms, and we're trying to get to mass, so we're going the other way. So we're taking our 5.00 times 10 to the 20 atoms. We know that there are 6.022 times 10 to the 23rd atoms in 1 mole. We know that 1 mole of cobalt is 58.93 grams from the periodic table. And when we get that, is 4.89 times 10 to the minus 2 grams of cobalt. That looks like 0.0412. Oops. One too many. 0.0489. That's what that looks like on your calculator. So you'll see it. It might come up like this, and if you put it in scientific notation, it'll look like this. But you can tell because it's 1, 2 in, right? Grams cobalt. Now, over here, it doesn't just ask for the mass, it also asks for the number of moles. So we can actually calculate that if we just sort of stop here. This will give us the number of moles because we have atoms to moles. And if we just don't keep going, then we can calculate the number of moles. So this one, if we just stopped right there and didn't calculate with the grams, we would have 8.30 times 10 to the minus 4 moles of cobalt. Okay. All right, so one more. We're going to go up a little bit. Here we go. Juglone. A dye known for centuries is produced from the husks of black walnuts. Let's see if I can get this focused a little better. Okay, so we want to calculate the molar mass of juglone. So we just simply take our 12.011, this is C, times 10, which is 120.11. And then we take our H, which is 1.008 times 6, and this is 6.048. And our 16.00 for oxygen times 3 is 48.00. And when I add these all up, that does not look like an 8, I get 174.1 grams. This is the molar mass, which means this many grams is equal to 1 mole. Now, this is the part A. Now we want to do part B. A sample of this many grams of juglone was extracted how many moles? So we have grams, and we're going to how many moles? So 1.56 times 10 to the minus 2 grams. And we're trying to get to moles. So we use our molar mass. We put our moles down here, 174.1 grams per 1 mole. And this is 8.96 times 10 to the minus 5 moles of juglone. Okay.